Texan Global School. Angles. In this class, we will analyze the concept, notation, and classification of angles. Nils points out that an angle is the opening between two straight lines or sides drawn from the same point called vertex. Specifically, an angle is a figure generated by the rotation of a half-line or ray around its endpoint, from an initial position to a final position. The amplitude of the rotation is the measure of the angle. The angles are represented with capital letters, Greek letters, or the indicated symbols. Any of these forms, such as angle A, O, B, angle A, or with a Greek letter like theta, are used to represent an angle. The unit of measurement for angles may be degrees, radians, or mils. A degree is the magnitude of an angle whose vertex is at the center of a circle and whose sides intersect an arc of length equal to 1/360th of the circumference. An angle of 1 degree can be divided into 60 equal parts called minutes. Each minute can be divided into 60 equal parts called seconds. Let's see an example. We will transform 35.41 degrees into degrees, minutes, and seconds. We first take the decimals 0.41 to transform them into minutes using a rule of 3. 1 degree equals 60 minutes, so 0.41 degrees equals how many minutes? We solve the rule of 3. We can see that the units of degrees cancel out, leaving the minutes. Simplifying results 24.6 minutes. Thus obtaining that 35.41 degrees are equivalent to 35 degrees 24.6 minutes. Again, we take the decimals 0.6 to transform them into seconds using a rule of 3. As 1 minute is equal to 60 seconds, so 0.6 minutes is equal to how many seconds? Likewise, we solve the rule of 3. Results 36 seconds. Therefore, 35.41 degrees equals 35 degrees, 24 minutes, 36 seconds. In this other example, we will transform 45 degrees, 58 minutes, 12 seconds into degrees. We will transform the 12 seconds into minutes with a rule of 3. Because 1 minute equals 60 seconds, 12 seconds is equal to how many minutes? We solve the rule of 3. Results 0.2 minutes. That value is added to the given 58 minutes. Hence, we have 45 degrees, 58.2 minutes. We will convert the 58.2 minutes to degrees with a rule of 3. Since 1 degree is equal to 60 minutes, 58.2 minutes is equal to how many degrees? Likewise, we solve the rule of 3, resulting 0.97 degrees. We add the 0.97 to the 45 degrees. Therefore, 45 degrees, 58 minutes, 12 seconds equals 45.97 degrees. A radian is the measure of an angle whose vertex is at the center of a circle and which intercepts an arc on the circle equal in length to the radius. It is important to note that pi radians equal 180 degrees. With this relation, we can transform from degrees to radians and vice versa. In this example, we will transform 2 pi radians into degrees. We can perform the transformation with a rule of 3. Because pi radians equals 180 degrees, 2 pi radians, how many degrees equal? Solving the rule of 3, we see that the radian units cancel out, resulting degrees. Simplifying, we see that 2 pi radians equal 360 degrees. We will now analyze the classification of angles according to their measure. An acute angle is an angle greater than 0 and less than 90 degrees. Right, like the angle that measures 90 degrees. Obtuse is the angle that measures more than 90 and less than 180 degrees. Straight, which measures 180 degrees, and coterminal or full angle, which measures 360 degrees. Another classification of angles includes complementary and supplementary angles. Complementary angles are those that, when added together, form a 90-degree angle. Supplementary angles are those that, when added together, form an angle of 180 degrees. Let's see an example. We will find the value of the angle A if B measures 32 degrees. Since A and B are complementary angles, then we will write the equation of A plus B equal to 90 degrees. In the image, we specify the given value of B and indicate the unknown variable. We then substitute the given value of b in the equation. Using properties of equations, we solve to obtain the value of a. As we can see, a measures 58 degrees. With the same diagram, we can verify that if we add the complementary angles, the result is equal to 90 degrees. In this other example, we will find the value of c, given the angles a and b, with values of 55 and 80 degrees, respectively. The diagram shows that they are supplementary angles. So, we will write the equation of a plus b plus c equal to 180 degrees. We substitute the given values of 55 and 80 degrees into the equation and isolate to get c. Results that c is equal to 45 degrees. With the same diagram, we can verify that if we add the supplementary angles, results 180 degrees. Additionally, the adjacent angles are two angles that have the same vertex and a side in common. In the diagram shown, angle A is adjacent to C, but they are not necessarily equal. The opposite angles are those that have the vertex in common and the sides of one are the prolongation of those of the other. In the same image, A is opposite with B, and they are always equal. The angles between parallels include alternate interior angles, which have the same magnitude and are those that are formed with the oblique line within the parallels. C is the same with F, and D is the same with E, since they are alternate interior angles. The alternate exterior angles are those that are formed with the oblique line outside the parallels and have the same magnitude. A is the same with H, and B is the same with G, since they are alternate exterior angles. Finally, corresponding angles are those formed by the oblique line with each of the parallel lines are on the same side and have the same magnitude. Let's see an example. We will find the value of each of the indicated angles between parallel lines if A is equal to 41 degrees. Since A and B are supplementary angles, then A plus B equals 180 degrees. Substituting the given value in solving results that B equals 139 degrees. Now, analyzing the angles between parallel lines, we can see that the opposite angles include A as the same with D. Also, B is the same with C, E is the same with H, and F is the same with G. Now, D is the same with E because they are alternate interior angles. C is the same with F also. Finally, alternate exterior angles are A as the same with H and B equals G. We can see that if we draw zigzag lines, we can easily identify the angles that are equal. The last classification of angles defines a positive angle as one with the counterclockwise rotation of the terminal side. Conversely, an angle is negative if the rotation of the terminal side is clockwise. Texan Global School. Global online learning. Knowledge for the world. www.texanglobalschool.com